So this is the activity that we started last Wednesday. This was meant to be a map of the Cal City East Bay campus. Each stick figure is a student in the student population, and each number above the stick figure is the height of that student. So this over here is the distribution of the heights of the Cal State East Bay population. So we're imagining that there's a lot of shorter students on the campus and fewer taller students out here. And we're also imagining that the mean of the population is 60. The mean of the students' heights is 60. The first part of this activity is selecting samples of 4 people. So the first step is just selecting your first sample of 4 people and recording their heights. I wanted you to pick a color to use for samples of 4, and then I'm using green, and pick whichever people you want to be your first sample of 4 people. Let's say I pick these 4 people right here, and I record their heights. So if this is my first sample of 4 people, I just put 1s next to my 4 selected people. So here's a 1, here's a 1, here's a 1, here's a 1, and that shows that these 4 people are all in my first sample. So this is my first sample of 4 people. What I do now is I go to this, you'll go to this other worksheet that I gave you. After you label those 1s, like I showed you on the map, you'll take those 4 values from your first sample and you'll write them under sample 1. So these 4 people's heights are 62, 65, 63, and 63. So the next step is to go here and write out their 4 heights under sample 1. So 62, 65, and 2 63s. It doesn't matter what order you write out the numbers under here, as long as you put all 4 numbers under sample 1. Next, after you write these out, the 4 heights from your first sample, you'll calculate the mean of sample 1. So you'll add the 4 heights and divide by 4. So add the 4 heights and divide by 4. The sample mean comes out to 63.5. Yours won't come out to that same number because you might have selected a different sample of 4 people than I did, but you would just put your 4 values under here from your first sample and then calculate the sample mean. And then you would put x bar 1 for the mean of sample 1, and then write what the mean of sample 1 came out to. This is 63.5. That's the mean of my first sample. Next, the third step would be to go to the map and go to this n equals 4 number line and find that sample mean of 63.5 that I calculated. And then right above 63.5, put x bar 1. And it doesn't matter if it's exactly above 63.5, just try to put it roughly in the area above 63.5, like I did here. And try to do it in the same color that you used for these 1s that you put labeling the people. If you didn't use the same color, then you don't have to worry about it, but it's best if you can use the same color so you can match them up. Once I've done this, I'll pick my second sample. And when you do this, you can pick whichever 4 people you want to pick. Let's say I pick these 4 people to be sample 2. And I'm recording their heights. The heights of my second sample are 67, 52, 60, and 63. Now I'll go back to this worksheet and write those 4 heights in here for sample 2. So the heights are 67, 52. It doesn't matter what color you use on this worksheet right here. You can just use a pen or a pencil. 67, 52, 60, and 63. Those are the 4 heights in my second sample, in the sample that I labeled with those 2's. Next, I calculate the mean of sample 2 by adding the 4 heights and dividing by 4. You don't have to show your work for adding and dividing in this activity. You just make sure that you calculate the means correctly. So this would be x bar 2 because it's the mean of sample 2. And for me, it comes out to 60.5. For you, it'll come out to a different number, depending on which sample you chose. Next, once you've calculated the mean of sample 2, go back to that number line again. Find the mean of sample 2 on the number line. Mine is 60.5, so I would go to 60.5, which is just slightly above 60, and I would write x bar 2 above 60.5. So the mean of sample 1 came out to 63.5, so I put x bar 1 above 63.5. The mean of my second sample came out to 60.5, so I put x bar 2 above 60.5. And you don't have to do it exactly above the number, because that's probably not possible, but just try to make it roughly above that number as best as you can. Next, I would do the same thing over again, and I would pick sample 3. I would pick the 4 people, and I would label those 4 people with 3's. And so far I've been sticking with the same color. I'm using green, and I'll show you why I'm sticking with the same color. So what if I pick this person, that person, that person, and in the directions I told you that I wanted at least some of your samples to overlap. So what if I pick this person who is also a member of sample 1, and they'll be the 4th person in sample 3. So now, 4 people in sample 3 have heights of 50 up here, 50, 52, 65, and 66. Those are the those are the heights of the 4 people in sample 3. So I would go back to that other worksheet, and under sample 3 I would write 50, 52, 65, and 66. It doesn't matter what order you do them in, as long as you put the 4 numbers under here. Then you would calculate the mean of sample 3. You would add these 4 numbers and divide by 4. And I get 58.65 this time. So 58.65 would be x bar 3. I'm sorry, 58.25. Once I do this, I'll go back to that number line again and put x bar 3 above above 58.25. So this is 58.25 is a little bit below 60, so I'll put x bar 3 right there. And that's roughly above 68 point, it's roughly above 58.25, which was the mean of sample 3. You'll repeat these same steps until you finish all 15 samples of 4 people. So you'll keep doing it over and over again with sample 4, sample 5, sample 6, sample 7, until you finished the 15th sample. And then at that point you'll have 15 x bars under here on this number line. And you have to make sure that each of those 15 samples that you select has 4 people inside of it. You have to keep using the same sample size of 4. Once you've finished all of that, and you have your 15 x bars above the number line, draw a curve around those 15 x bars. And draw a curve not outlining just those 15 x bars, but outlining the shape that you would have if you had actually calculated the means of all possible samples of 4 people. If you had created the complete sampling distribution for the sample size of 4. And we know that if the population is skewed like this, and you're taking a small sample of 4 people, the possible samples are skewed just like the population. So you would be drawing a skewed curve around this number line. And make sure to leave some empty space in here, because just to show how the curve is outlining not just your 15 samples, but all possible samples of 4 people. After that, after you've drawn the curve, after you have all 15 x bars and you've drawn the curve, you'll have to label mu x bar, which is the mean of all of the sample means under the curve. So mu x bar is the mean of the sample means. So, and we know that mu x bar is the same as mu. Under this curve, we have the means of all possible samples of 4 people, and all of those sample means have a mean of their own, which is mu x bar, and that equals the population mean of the individual population members. So if the population mean is 60, mu x bar is 60. So just put a mu x bar under 60 like that. It doesn't matter what color you do it in, I just was still using green. And then after that, you'll be doing some labeling of your curve. In my directions, I'm telling you to make an arrow around here, and you'll need to write a phrase up here that says something like, "This is the sampling distribution that includes the means of all possible samples of 4 people," and then put an arrow to the curve to show this is what the curve stands for. So you'll have that phrase up here and then the arrow pointing to the curve. You'll also need 3 other arrows. You'll need to make an arrow to the left end of the curve and write a phrase up here that says, "These are the samples with sample means that underestimate the population mean." Because all of these sample means are under 60 and under the population mean of 60. You'll make an arrow toward the right end of the curve and say these are the samples with sample means that overestimate the population mean. And then the reason why you're doing that is because all these sample means are above the population mean of 60. Then you'll draw one more arrow somewhere toward the center of the curve and write out the phrase, "These are the samples with the sample means that most accurately estimate the population mean." And you're doing that because you're saying that these sample means are the closest to the population mean of 60. So you'll have these 4 arrows, and then you'll need one more arrow pointing to the mean of your actual sample. In this activity, I was saying that x bar 1 is the mean of your actual sample, because you notice how in the worksheet I say above sample 1 that it's your actual sample. I want you to think that sample 1 is your actual sample that you've actually selected, and the other 14 samples are just possible samples that could have been chosen from the population. There are just 14 other possible samples. So since sample 1 is your actual sample, you'll make an arrow pointing toward x bar 1. And you'll say down here, this is the mean of my actual sample. And you'll also need to make a note about whether your actual sample, whether the mean of your actual sample underestimates or overestimates the population mean. If your x bar 1 is above 60, then your sample mean is above the population mean, so you would say, my sample mean overestimates the population mean. But if your x bar 1 turns out to be below 60, below the population mean out here on the left side, you would make a note that says, the mean of my actual sample underestimates the population mean. So under this arrow, you're saying that this is the mean of my actual sample. You're making a note that says whether or not that sample mean underestimates or overestimates the population mean. You also need to make another note that says how accurate the mean of your actual sample is. If your x bar 1 is far away from 60 in either direction, to the left or to the right, then you would say my sample mean is not very accurate. But if your x bar 1 happens to be close to the population mean, like how this one is actually pretty close, then you would say the mean of my sample is pretty accurate. So say that this is the mean. Say this is the mean of my actual sample. Say whether or not it underestimates or overestimates the population mean, and say how accurate your sample mean is. And that finishes the labeling of all of this. The next step would be to do your next number line down here, which is the samples of 30. And that's doing the same steps over again, just with samples of 30. I wanted you to switch to a different color if you could, because when you're selecting your first sample of 30, you'll be putting a 1 next to your all of your 30 selected people. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to pick 30 people. I can reuse people, so I could put a 1 here. I could put a 1 here. I just have to do it with 30 different people. And once I've selected my 30 people, and I've written this this 1 next to the 30 people in my first sample, once I've chosen my first sample of 30 people and I've recorded their heights, I'll go. So this worksheet with the samples of 4 has already been completely filled out. So you'll have to go to another worksheet that I gave you just like this one, because I gave you more than one, and use that one for samples of 30. So once you've selected your first sample of 30, under sample 1, write out those 30 heights under here. If you can't put them in one column, just make different rows or however you need to do to fit the 30 heights in here. And then add those 30 heights and divide by 30 to get the mean of sample 1. Put x bar 1 equals that sample mean. Once you've done that, just like before, go to the map. Now you're not working with this number line anymore. You're working with samples of 30, which is the other number line down here. Above that other number line, look for where your sample mean is for x bar 1 and put an x bar 1 above it. So once you've added those 30 heights under sample 1 and divided the total by 30, you'll get the mean of your first sample of 30 people. That'll be x bar 1, and then put that x bar 1 above the other number line down here. Once you've done that, you need to pick your second sample of 30 people. The reason why I suggested, or I wanted you to use a different color is because if I had continued to use green, I wouldn't be able to know if this is a member of the first sample of 30 or if it's just a member of the first sample of 4, because they would just all blend together. So you should use a different color. Once you switch to samples of 30, you should switch to a different color like I did, or maybe switch from pencil to pen. When I pick my second sample of 30 people, I just need to find 30 people and put 2's next to them. And with your samples of 30, the samples will definitely overlap because there's only about 47 people on the map. So this person was in sample 1, the first sample of 30, but I could reuse them for sample 2. The only thing I can't do is reuse the same exact sample twice. So, for example, I couldn't just go back to the same exact group of 30 people that I chose the first time and write 2's next to all of them and pick the same exact group of 30 people twice. So I can reuse people. So I can put a 2 there. I could put a 2 here. So this red 2 is saying that this is a member of the second sample of 30. Once I've finished all of this, once I put a 2 next to 30 different selected people, I'll take those 30 heights in sample 2, write them all under sample 2, write those 30 heights all under sample 2, calculate the mean of that sample by adding and dividing by 30, and put x bar 2 equals that number. Once you do that, you'll go back to the n equals 30 number line, which is down here off the screen, and you'll put x bar 2 above that number line. Then after that, you'll go and select your third group of 30 people and put a 3 next to each of them. And you'll repeat the step over again. Then you'll put the 30 heights under sample 3, calculate the mean, and put x bar 3 equals that number. Then you'll go back to your number line for n equals 30 and put x bar 3 above the sample mean. And for samples of 30, you won't have to do it 15 times. I just want you to do it 5 times. So you'll do x bar 1, x bar 2, 3, 4, and 5. You'll do 5 different x bars, and then you'll be finished. Once you have those 5 x bars above your other number line down here, you'll do the same thing. You'll draw a curve around the number line, showing what shape you would have if you had actually calculated the means of all possible samples of 30 that could be chosen from the population. You'll have to think of the central limit theorem, because it says that if the population is skewed like this, if the people are skewed, then possible samples of 30 would still be, the possible samples of 30 would still follow a roughly normal shape. So you would be drawing a roughly normal curve around your other number line. And just like before, your 5 x bars will be under the curve, but leave a lot of empty space under there to show that It's the means of all possible samples of 30. You're not just outlining your 5 selected samples of 30. Once you draw that roughly normal curve around the number line, you'll do the same labeling. Mu x bar under 60, because just like how the possible samples of 30, just like how the x bars of all possible samples of 4 had a mean of 60, the x bars of all possible samples of 30 will also have a mean of 60. So mu x bar won't change. So put mu x bar under 60 below your third number line down here. And then do this same labeling. Label underestimating, accurate, overestimating. Say this is the sampling distribution of all possible samples of the means of all possible samples of 30 people. Make that arrow just like before. And also label your actual sample, which is the x bar 1 again. And just like you did here, you'll do the same thing. You'll say, this is my actual sample of 30 people. You'll say whether or not it underestimates or overestimates the population mean, and you'll make a note on how accurate it is. So the first half and the second half are the same thing. It's just the first half is with samples of 4, the second half is with samples of 30. And with the samples of 4, I wanted you to do it 15 times. For samples of 30, I wanted you to do it just 5 times before you stop and make the curve.